Hey math kids, today we're going to talk about limits at infinity. And in your book, they give us a little bit of guidance. Okay, so if we have 1 over x raised to an exponent, and we plug in infinity, that number is just going to get bigger and bigger and bigger and bigger. And so if we do 1 over a very large number, we approach 0. So that's what that's saying. Then the limit as x approaches negative infinity of 1 over x to the n, that equals 0 for all n contained on the positive integers. Okay. Alright, so let's move on from there. So now the first problem, the limit as x approaches infinity of 2x plus 3 over x minus 4. So what we want to do is we want everything to be like divided by a power of x is the approach. And so this part is going to, if we divide, so we're going to divide the top by x and the bottom by x. And so this divided by x is just 2, and then 3 over x. Then we divide this by x, 4 over x. Now, if we plug in infinity, what's going to happen is this is going to go to 0, and this is going to go to 0. So we'll be left with 2 over 1, and so the limit is just 2. Okay, let's try another one. Limit as x approaches infinity of x squared minus 3x plus 2, 1 minus x squared. Okay, once again, we want everything to be divided by a power of x. And so our biggest power of x on the top or the bottom is x squared. And so the approach is to divide everything by x squared. X squared divided by x squared is just 1. If we divide this by x squared, we get negative 3 over x. And this will be 2 over x squared. And then 1 over x squared minus 1 if we divide each of those by x squared. Now we know this, this, and this will all go to 0. And so we're going to be left with 1 over negative 1, so the limit is negative 1. Okay. Limit as x approaches infinity of x squared plus x plus 1, x minus 2. Same approach, divide everything by x squared. So that's 1 plus 1 over x plus 1 over x squared. 1 over x minus 2 over x squared. Now, if we do that, we're going to get this, 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 and this all go to 0. So we have 1 over 0, and so it does not exist. Okay. Okay, moving on. So if we have f of x is equal to 2 minus x, 1 plus x, we need to discuss the behavior of this near its asymptotes and hence deduce their equations. Okay. So what we're going to do, we're just going to plot it, and feel free to use a graphing calculator if you want to do that. We see that there's going to be an asymptote at negative 1 because that would create division by 0. If we want to find the horizontal asymptote, we can quickly go through the algebra on that. So I'm going to multiply both sides by 1 plus x. So we have y times 1 plus x equals 2 minus x. Distribute the y. We want both the x's on the same side. So I'm going to add x, and also subtract y, So we have yx plus x equals 2 minus y. Factor out an x. Divide by y plus 1. So x equals 2 minus y over y plus 1. So we have a horizontal asymptote. We create division by 0 at negative 1. And so we'll have a horizontal asymptote at negative 1. Okay. And our graph is just going to follow that. Like that. Okay. So we want to describe the behavior as we're approaching those asymptotes. And so as x approaches negative 1 from the negative side, so as we're traveling this way, then f of x approaches negative infinity. So as we go towards this asymptote, so we start on the negative side, which is the left, and we go towards the right, towards the thing, we go to negative infinity. Now, if we approach negative 1 from the positive side, we're going to positive infinity, because we're kind of traveling this way on the graph. All right. Now, if we're talking about the y, so if f of x is approaching negative 1 from the negative side, so now we're talking about this asymptote. So if we're approaching that from the bottom, so we're going this direction, we end up going in the negative infinity direction as far as x goes. And the last one, as f of x approaches negative 1 from the positive side, so if we're approaching this line from above it, we go down here, and so the x values are increasing, so that's going to be positive infinity. Okay. And yeah. Now part B says, if they exist, state the value of the limit as x approaches negative infinity of f of x and the limit as x approaches infinity of f of x. So, so if we're traveling on the function, so once again the purple is what the function is. So if we're going down, or sorry, if we're going to the left, on this, we are, like as x goes more and more, sorry, right here, if x goes more and more to the left, we're bound by this negative 1. And so the limit as we go, so basically it's saying as we go really far left, what does our y value do? Our y value, we get closer and closer and closer to negative 1. So our limit for this top one is negative 1. Now this one, it's saying as we go really far to the right, as x gets really, really big, meaning going to the right, what does the y value do? Well, the y value gets closer and closer to negative 1. So both those limits are the same. Okay, now we need to find the limit as x approaches negative infinity of 3 minus e to the negative x, and the limit as x approaches infinity of 3 minus e to the negative x. Alright, so it's the same function, just different different situation, or asking for the negative infinity and positive infinity. So let's draw the graph of this. Once again, feel free just to graph it on a graphing calculator. 1, 2, 3. We see that there's going to be a horizontal asymptote. Whoops. At 3, and it crosses at 2. Okay. So, when we're doing this, if we're going to the left, this is essentially just saying, as we go really far to the left, what do we do? Well, this goes to negative infinity, and so that's what's called, it diverges. And if it doesn't go to a finite value, then we say the limit does not exist, because it's not bound by anything, so there is no limit. Now this one is saying, as we go to the right, so as we're traveling this way, we are bound by 3, and so the limit is equal to 3. If you have additional questions, please come to Math Lab. Until then, calculate.